All right, here, example number 2. If sine theta equals x for an angle in either quadrant 4 or quadrant 1, find an expression for sine of 2 theta in terms of x. So I drew a picture of my triangle, angle theta. Sari thought I was talking to her, apparently. Anyway, so we're going to, sine is x, so x over 1, opposite over hypotenuse. We use Pythagorean theorem to find the adjacent side, so that would be the square root of the hypotenuse squared, so 1 squared, which is 1, minus the leg, the opposite leg, squared, so x squared. So there's the adjacent leg. So then when we use our formula for the double angle here, we will have 2 times the sine of theta, which was x, times the cosine of theta, which is this adjacent leg divided by 1. So that's just that. And then we just put it all together and we get this expression that can be used to find the double angle of sine anytime we know the ratio for the single angle of sine. So for example, if we had the sine of 30 and we wanted to find the sine of 60, we know the sine of 30 is 1/2. So we could plug in the 1/2 everywhere where we have an x, and we'd have 2 times 1/2, which is 1. And 1 minus 1/2 squared, so 1 minus 1/4 is 3/4. If we simplify the square root of 3/4, we get the square root of 3 over 2, which is the sine of 60. So it works just like it says it would. Okay, question 3. Let's verify the following identity. We're going to start with the right-hand side this time because it is much more complicated than the left-hand side. So if I can get my pen to work. So start with the right-hand side, and since our answer wants to be sines, I'm assuming we should probably change our tangents to sines and cosines. So I'm going to start by changing this tangent to sine theta over cosine theta. And then the denominator of that would be 1 plus sine squared theta over cosine squared theta to get tangent squared. Okay, fractions in a fraction. We never want to keep that way, so let's start working on simplifying it. One of the things we want to do to get this simplified is to make sure we combine these fractions together. So to turn 1 into a fraction with a common denominator of cosine squared theta, we want to multiply it by cosine squared theta over cosine squared theta, because that has a value of 1, but it has the denominator of the other fraction, cosine squared theta, right? So now we have, let's go ahead and, well, I'm just going to rewrite this fraction first. So we have 2 sine theta. I'm going to go ahead and let the 2 float up here with the sine. Like 2 over 1 is still 2. And then the cosine here. And then let's add these fractions together in the denominator. So that would be cosine squared theta plus sine squared theta over cosine squared theta. So now I'm going to do the little copy dot flip thing so that we're copying the numerator and we're multiplying by the reciprocal. All right, so I start with my numerator, 2 sine theta over cosine theta. And I flip over the denominator, so I'll have cosine squared theta over cosine squared theta plus sine squared theta. I'm kind of feeling like I don't want to write that whole thing right now. So, because I know that that thing is just going to turn into 1, right? So can I just put this over 1? Anyone have any issues with me doing that? So Pythagorean. If you wrote it all out, that's fine too. Okay, so now let's simplify this. So one of these cosines cancels, right? Boop. One of those cosines cancels with this cosine. And this is already a 1, so now we're left with a 2, a single sine theta, and a single cosine theta because the cosine squared reduced with the cosine in the denominator. And that is, I guess I shouldn't have boxed that yet. We learned that identity today. That identity is the sine of 2 theta. It's much easier to verify and simplify these things if you have a bunch of identities memorized, because then you'll just recognize them and be able to see when you're getting that answer because it matches the identity that you have memorized. Any questions on that one?